All right, I had a student reach out to me after working through Chemistry 1125 and said, we got stuck on page D. Could you please give us some more help? So let's walk through a few of the types of problems that we have here on page D, where we have to come up with the chemical formula based on the name, and then some where we have to come up with the name when they give us the chemical formula. You will need your periodic table for these, and then on the top of page 6 we have some of the common polyatomic ions. It'll be important that we use that. And then as well here on page 9 are the rules for assigning oxidation numbers. The big rule is that the positive and the negative oxidation numbers have to balance out. So we have to have the same positive charge as the negative charge for any compound. So, and the positive ones always come first, which means on the periodic table, they are going to be primarily over here on the left. They're almost always metals. Okay, so they come first, and they are going to get rid of electrons, which means that they end up with a positive charge. Okay, that's their oxidation number. Whereas the elements over here, the halogens, tend to take on a negative charge, take on an electron, which gives them a negative charge. And then we have a whole group of polyatomic ions that we saw there on page 8, rather page 6, that together as a gang have one number, okay? Let's take a look at some of these here. Potassium, so we look up the symbol for that and we see that it's K, and then we can see that it is in family 1, which means it has a positive 1 oxidation number. Then bromide means it's coming from bromine. Bromine is in family 7, it's element 35. So it's in the halogens, and all of those elements have an oxidation number of -1. So we have positive 1 here, -1 here. So we just are able to put those two together, okay? And we don't actually put the numbers when we write the final answer, okay? Barium is in family 2, so it's going to have a positive 2 charge. And chloride means it's coming from chlorine. Chlorine is in, again, the halogens, so it's a -1. Uh-oh. So they don't match. It's not the same. Now we can write down Ba for barium, Cl for chlorine. Now what we're going to do is we're going to take the -1 charge and the positive 2 charge, and then they cross, okay? And those become the subscripts. So the positive 2 charge here means that I need 2 chlorines to balance 1, so I don't need to write the 1. But I need 1 barium with positive 2 charge, and then 2 times -1 will balance out, and so the positive and negative charges then will be equal. All right? Now let's talk about this one. This is an interesting one, chromium, and that is element 24, so it's Cr. And then we have oxygen. Now oxygen is always -2. That's one of the rules, I believe, on page 9. And chromium can have a variety of charges depending on how it's interacting with the elements. In this case, we see this Roman numeral, and that tells us, the Roman numeral tells us the actual positive charge, okay? There's no gimmick, there's no game, it's real easy, positive 3. So now I have a -2 charge and a positive 3 charge, and now watch the magic again. We just go bing, and those are our subscripts, okay? So this subscript, this charge of 2 tells me that I have a subscript of 2, positive 3 means I have a subscript of 3 on oxygen. Let's check it out. 2 times positive 3 would be positive 6 for this half. 3 times the -2 would be -6. So my positive 6 and -6 balance each other out. Perfect. Let's look at calcium carbonate. This is one where we have to look at the table on page 6, and we see that carbonate is, let me just make sure, CO3 with a -2 charge, okay? CO3, and it has a -2 charge. Calcium is, oh man, this is easy. Calcium is a +2. So I only actually need one of each. Isn't that cool? One of each, +2, -2, they cancel each other out. So we have a balanced molecule right there. Okay, we don't need to go any further. Hopefully that gives you a little feel for some of the other problems on the pages. They do give you quite a bit of practice, so this is good. Let's talk about coming up with a name for this. Here's the same CO3, carbonate. All right, so we'll just write that, carbonate. And then we can just write the name of the element in front of it. So this one, magnesium carbonate. Now here we have copper, and it's bromine, but I don't write bromine, I write bromide, copper bromide, but I need, copper is one of those ones that can have different charges. Okay? So I need to put a Roman numeral in there, and I got to figure out what Roman numeral. Well, I know that I only need 1 copper, because that's what it tells me, to balance 2 bromine. So bromine is going to be the key. Let's figure this out. Bromine is a halogen, family 7, so it's a -1 charge. So each bromine is -1, which means this half will have to be +2, because 2 times -1 will give you a -2 charge for that half. So this half has to be +2. Well, if that oxidation number, that charge is +2, that is the Roman numeral. Da, 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 da. Okay, it's that easy. So we'll just put Roman numeral 2 in the parentheses. All right, so there's no magic. It's easy. You just figure out what is the charge of whatever they give me for the -1, and then look at what is given here, and you can figure out what the Roman numeral should be if it has a variety. Okay? I hope that helps. I think that should help. And you know, go on and do. This is definitely a concept that they want you to master and be able to do on upcoming checkups, I believe, as well. So do your best, score right away, make sure you're on the right track, maybe even score when you get halfway through, and make sure you're doing it right before you do the whole page and discover you did something wrong, okay? And do let me know if there's other problems or questions that you have along the way.